So Unit 4, Lesson 1. This unit is not broken down into modules. It's broken down into several lessons instead, because they all kind of go together. And I didn't see a good way to break them apart, rather than just calling it, Module Part 1 and Module Part 2. So the first thing we're going to talk about is a concept of method decomposition. So you take a task, and you break it down into smaller tasks. For example, let's talk about making a peanut butter and jelly sandwich. Everybody knows how to make a peanut butter and jelly sandwich. Some of you may do it the wrong way. Hopefully all of you do it the right way. The correct way of making a peanut butter and jelly sandwich would be to put the peanut butter on both sides of the bread, and then you put the jelly on one side, not both sides because that's silly, and then you close the sandwich, cut off the crust, cut it in a half and a diagonal, cut it in a half and a diagonal. Again, you have 4 pretty little pieces. So you may disagree with that's the right way of making a peanut butter and jelly sandwich, but that's okay. The thing that I didn't talk about is, where does the peanut butter come from? Well, if we really write a script to have a computer do this, we'd have to tell the computer to go to the supermarket, buy the peanut butter, bring the peanut butter home, open the jar, get a knife from the drawer, use the knife to scoop the peanut butter and put it on the bread, ... We don't have to do any of that because that's already done for us. That's assumed. There's a shopping part of this process. At some point, you went shopping, and those ingredients are in the house. That's already been done. That's part of something else. That part of the task is separate from this part of the task of actually making the sandwich. And we can do that with most tasks. Most tasks can be broken down into smaller segments of tasks. Wouldn't it be awful if every time you tried to do something, you had to do every single step from start to finish all at once, and how to rethink that process all at once? Maybe going so far as saying, all right, I went to the store and got the peanut butter, now I have to go back to the store and get the jelly, because I didn't get both at the same time. Those are two, separate things. Get the jelly, get the peanut butter, then get the spoon for the jelly, because you got to use a spoon for jelly. You don't use a knife for jelly. That's silly. And then now you're thinking about it, going, wait, that's right. We probably should use a spoon for jelly. I've been doing it wrong all this time. So, yeah, that's how you build a sandwich. You break the tasks down to other tasks because those pieces were already taken care of for you. It's method decomposition. When you take a larger task and break it down. It also gives you the ability to reuse it for other things. Like that whole task of going to the store and shopping isn't just for making a peanut butter and jelly sandwich. It's for making dinner. It's for making breakfast. It's for any time you need something at the store. There's a method where you input a list, a shopping list, and you go to the store and shop. You don't shop for individual things individually. You don't go to the store every time you need something. At least my wife yells at me every time I do that, so I try not to. Insert laugh. Thanks. I'll put the laugh track in later. Okay, so, big idea. Take a large, complicated problem and break it down into smaller pieces. These are called methods. Each of these pieces does one specific job in the program. Now, you'll find that we don't know how every method works. Dot next int. Dot next line from the scanner class. We just know what it does. We don't really know exactly how it works. How does it get the next int? How does it get the next line? I kind of have an idea. You probably have no idea. What does it actually do to get that input? Doesn't matter. We don't need to. That is another concept called Blackbox Abstraction, where we don't need to know exactly what everything does. Not every method has to be explicitly explained to us for us to use it. That's a big advantage in Java, because you can do a lot of things based upon the work of others. You can use a library of classes and methods that other people have built and accomplish a lot of things. Suppose, for example, you wanted to learn how to program video games. Like, wow, I'm going to have to figure out how to put pixels on the screen. I'm going to have to figure out how to render 3D objects. I'm going to have to figure out how to do physics in computer science. Nope. That's all already done for you in Unity. Somebody wrote libraries to handle all of that, then all you have to do is put it together using Java. Somebody already did all of that work for you. You can use that and be creative and create something new. It sounds almost like cheating, but it's really not. You're building upon other people's work. Imagine if every time you use the computer to type in a paper, you had to type in binary. Because that's really what computers understand, but somebody did the work for you and built an application that you can use. This is no different. Somebody builds applications and tools for you to use. Someday, some of you might build tools and applications and libraries that other people can use. A good place to find libraries like this is on a place called GitHub, G-I-T-H-U-B. This is where programmers often put up open source projects in order to see what those projects are and share their information. By the way, January 17th is the official celebration of Open Hardware Day. Hardware Freedom Day, that kind of celebrates this idea of open sourceness, of things being available for everyone to use and share. And there's a big sharing community inside of computer science. In fact, there's often these things called hackathons, where you all try to get together and solve some type of problem. There's one right over in Princeton. You should check it out. So here are some methods that we have already used. Dot compare to, dot length, dot equals, and dot character at. We've used all of those. We've also used this one. Public, static, void, main. This is the main method. This is a method. It does something. In fact, every time we run a Java program, we have to run a main method. Some of you may have gotten this error when you're trying to run the different labs. No main method found. Something to that effect. Because you're running one of the classes. You're not running the quote-unquote driver program. Well, you're not running the main method. The main method is the method that kicks everything off. Java is designed to look for that initial method to set everything up and get started. And in fact, and we'll talk more about this later, but you see this right here? String, string. This main method takes parameters. You could type in Java, the name of the class, and then give it some parameters in strings like hello, 1, 2, and it would interpret those parameters and do something different than it would normally do. We find this a lot of times when we're writing command line programs. Anybody who's familiar with Unix or Bash or using Java command line, you will often type in other parameters after the program to get it to do stuff. Some of you may have done this and not known what you did. You know, sometimes we do that when we're running programs like in games or trying to get something kind of a workaround. Maybe you ran an emulator, you're not sure what you did, but it just told you to type in this big long command with then these different weird symbols after it. Essentially, you were running a method and sending it parameters. And we'll play with that at some point. So here's how we call a method. This is the method doStuff. And what's it do? Stuff. It prints out, this is a method. Let's talk about our structure here for setting up methods within the primary class here. So we have our class declaration. This says class. Then we have the name of the class. Typically, this is also the file name. The reason we make the file name and the class name the same is so when we go to use this in other programs, we know that the file name that we include is also the name of the class, and Java doesn't get confused. Some of you have found this an error where you named the file name something different than the class. That's a habit that we need to get out of. We need to start naming these classes with the file names. You have to really give it some thought when you do that from now on in the future. Next comes any methods that we might use within this class. Now, typically, there's some other stuff up here first when we're building classes, but we'll talk more about that when we get into classes. But what would come is the methods list. And in this method list, we're just telling it to print something out. Then we have our final method, which is the public static void main. Now, could we put this method after public static void main and would it still work? Yeah, Java will find it. It's a pain. It's less efficient, but it'll still work. And it's bad style to do that. Public static void main is the last method that you should put in the main class. Makes it easier to find stuff. So essentially what happens is we call Java to run this program. In the Java interactions panel, you could type in Java, the name of the class, and press enter, and Java would automatically look to run this main method. That's what it would look for. Once it runs this main method, it looks to see if there are any parameters. If there's any parameters, it stores them in the array str. You don't have to call this str. You could call it anything you want. You could call it happy birthday. You could call it anything at all. Doesn't have to be strings. Nope. It could be ints. It'd be a little odd for the public static void main not to be strings, but it doesn't have to be. Main is the name of the method. For this method, we have to use the word main. Any other method, we could use any word we want except for constructors, and we'll talk more about them later. Void, as we talked about, is the return value. What's this method going to send back? What type of information is it going to send back? It can only send one thing back. Methods can only return one thing. Now that thing could be an integer, could be any type of primitive piece of data, but it can also be an object, which kind of lets us work around that one thing idea. Objects are nice big packages that could hold lots of information. So yeah, we can only send one thing, but sometimes we can send a one big thing, a giant package. Static. Static means we don't need to construct anything. We can just call the method without having it associated with an object. It's associated with the class that it's in. So for example, the math class has lots of static methods. Math.abs is an absolute value static method. We don't need to construct a new math object every time we use it. That's what static means. Again, we're going to talk more about that later. And then finally, public, this has to do with the scope. Who has access to this? Well, it's public, so everybody's going to have access to it. There is another type of scope called private, which limits the access to the class that contains that method. Again, more topics for later. So there's a lot that's built in here in this one statement. We got so used to typing it and or copying and pasting it that we kind of ignored the significance of it. But there really is a lot in here that's giving us information about this method. And in fact, this parallels this method. It's public, which means everything in that class has access to it. It's static, which means we don't really need to construct a class for it. We could just use the class name, which in this case is something lovely like T1 Lesson 31 template. And we could call that method by saying t1 less than 31 template dot do stuff. So why don't we do that? Why don't we call t1 lesson plan 31 template dot do stuff? Why are we not using that name? Well, because Java has this ability to recognize that if you're not listing the class name, it assumes the method you're talking about is the one that's in the current class. So since I didn't say the name of the class here, and I just said do stuff, Java's assuming I'm referring to the method that is contained within the same class. In other words, these two are together. They're in the same class. So if I call do stuff, Java's going to look within this class for a method that says do stuff. And it's static, so Java's going to let you do that. So all the methods that we're going to be dealing with will be static for right now, in that we don't need to construct an object like we do with scanner class, or like we do with a string, in order to use it. Java knows do stuff, well, there's no class name in front of it, so it assumes that the class we're talking about is the class that it's in. So it's t1 less than 31 template. This would work if you did t1 less than 31 template. There's also another command that Java uses often to make it clear. It's the this command. And we'll talk more about that later. There's a lot of intro in this lesson, a lot of vocabulary. But we could say this dot do stuff to be really explicit, to let Java know that we mean to use this class. And say this dot do stuff. That sounds so unprofessional. Just say, yeah, just use this. But that's what they decided to code it as, so we can have a command that's called this. English teachers would be freaking out at this point, going, wait, you can't do that? Yeah, we can. It's Java. That's how we do it. We named the programming language after a cup of coffee, so yeah, we can pretty much do whatever we want at this point. So, we do stuff twice. That's one of the advantages of having a method, is we can use the same code over and over again. We can take code and say, hey, this is good. A good example of this is if any time you look at your program and you see that you use the same sequence of commands more than once, that should become a method. It's called refactoring your code, where you go through and you look to see, are you repeating yourself? If you're repeating yourself, then you should be creating a method for that. That method would then become something separate up here, and you would just call that method rather than repeating code. Some of you, I recall in some of your exercises, use that cut and paste method. We're like, oh, okay, I'm going to cut this, paste this, cut this. And then you end up with like missing curly cues and crazy errors, because cutting and pasting the right code doesn't work very well. It always ends up causing a bit of a mess. And most of the time you can figure out the mess, but it does cause a bit of a mess. If you're going to find that you need to repeat that code, you want to refactor your code and make sure that you're just writing a method for it and use that. It's an example of when you should decompose the problem. But if you're doing the same thing over and over again, that begs for, hey, this is something that can be turned into a method. So, method. Pieces of code that are given a name. Method goes above main. And the name lets Java find the correct piece of code. Very straightforward for a method. There are lots of different kinds of methods. They all follow most of these rules. Sometimes there is no main in the class. It's not a driver class. It doesn't have a main method. And at that point, all the methods go after the constructor, and we'll talk more about that later. But in terms of placement, no other order than that. And again, you could put a method after the main. I've done it before. It does work. Java finds it. It's just not clean. So let's take a look at another little example here. So if we want to write a method to print the word Java on the screen, we want to make it public. For right now, all of our methods will be static because we don't want to talk about creating classes yet. We're not to that point. Later on, we'll have different kinds of methods. Void, we're not going to return anything because we haven't really talked about returning information yet, how to do that ourselves. And then we got to give it a name. The naming structure for methods is typically a lowercase letter to start, and if the method is more than one word in the name, like print Java, all the words following the first word are uppercase. Java doesn't care about that. That's, again, a stylistic thing. So you'll find that you probably have started to recognize that in our exams, like character at, lowercase c, capital A, index of, lowercase I, capital O. It's a stylistic thing that most Java programmers use and kind of as, a standard in the industry. So finally, we just print out Java. That's what the method will do. Okay? In the main, we would call it, by calling it by name, print Java. This is our public static void main. Print Java calls that method. Then when we execute, it prints on the screen Java. So why do we use this? You can set it up a really long, tricky bit of code, and then every time you need to run it, you type in do tricky stuff, and it does it for you. So that's it. Catch you next time. There is a practice assignment. Take a look at that.